right, everybody. Thanks for joining us today. My name is Hunter Willis, and today we've got Dave Wharton on the line with us. He is head of cloud economics over at CDW. David, tell us a little bit about yourself before we get rolling with the episode here.
Sure. So I hail from Boston area. I am the the chief architect for the office of the CTO at CDW. And one of my major focuses is cloud economics. So I'm passionate about that. I'm also an avid sailor and also interested in art history.
Let's go ahead and get rolling. So when I ask people to come on the podcast, I always like to ask them what they're passionate about, what they're really excited about talking about, right? And so David said he wants to talk about GreenOps, and he's got a lot of stuff going on with that, and he's very experienced in it. So David, I really, like when people say GreenOps, most people are in the same ballpark about what they're talking about, but there's a lot of different definitions for that, and people have a lot of different things in mind. We all know that it's got something to do with like carbon emissions reporting from the cloud, but we also know there's other factors involved there, and again, different ways that people see that. So can you, when we're talking about GreenOps and the stuff that you're excited about in that regard, can you like level set with us? What do you mean when you say GreenOps? What do you think about and talk about in the different organizations that you work with? What are they thinking about and talking about? And then, we're like different perspectives on that too, right?
Right. So I would say, I'm sure most people are thinking, oh, great, another portmanteau for me to learn and figure out, et cetera. But it's really not that complicated. It's a subset, from my perspective, it's a subset of FinOps. It's FinOps in the lens of sustainability and carbon footprint reduction. So that's really what it is. So it's smart engineering decisions that lead to sustainable change, that reduce cost and reduce your carbon footprint.
Gotcha. And that can be everything from like, the different things that are affecting carbon footprint. Can you walk us through some of those factors, right? And when we're talking about cloud operations and also in that kind of FinOps conversation of efficiency, right?
Yeah, so I think, first of all, the thing that's top of mind, especially with the tariffs and downturn and all that fun, exciting stuff, it's just, of course, sarcasm. Customers are really concerned about cost, and they want to make sure that their spend is at least, trending on a plateau versus going up. And the best way to do that is through change management. And amongst some of those changes that you can make are some of these GreenOps decisions. So, reducing your spend because of, certain compute choices that you can make, whether it's leveraging ARM processing, shifting some of those x86 workloads over to ARM. And not all x86 workloads are ideal for that, but there are opportunities there. And then there's also processor based changes you can make that will also reduce your spend. But then also more drastically, I would say as much as 30%, you can reduce your carbon footprint by those changes. And that's particularly interesting, I think, for me, just because I really think, I think about all the compute that goes into AI, right? Or folks mining crypto, right? These are two things that are popular, crypto and AI. So that's leveraging a lot of CPU and or GPU. It's, I guess, Monero is probably the only one that's mined on CPU. But in the GPU space, you've got a lot of attention around, the workloads associated to mining currency and workloads associated to processing AI tokens and time to token and all that. So it's definitely top of mind. And I think it's important to be sustainable and to not, use too much electricity. Now, of course, the main attraction to go to the cloud is to help lower your electricity bill, right? Your power consumption bill for your company. But that doesn't mean that your company is lowering your carbon footprint. You still have workloads. You are still drawing energy. It's just that instead of paying the power bill, you're paying your cloud bill, right? So there's the use of electricity is still there because the workloads are still there. So it's important to make sustainable choices from an architectural standpoint that can impact not just your cost, but also your carbon footprint. I know that was the long-winded version. So.
I've kind of seen these devolving conversations on LinkedIn too, where people kind of in their messaging and when they talk about it, you see some people talk about cost efficiency and green ops as though like the carbon emissions and cost are linear or like directly correlated, let's say, but they're really not, right? It's not the case all the time, right?
That's true. Yeah, that's true. It's not, I mean, you could, yeah, some of your choices could be reducing cost. And but the efficiency is not super changed, right, in terms of metrics. However, but there are a lot of cases where you can lower your spend, and then it will directly correlate to lowering your carbon footprint as well. Now, right now, I think there's about 7 states that provide tax incentives as it relates to reducing your carbon footprint. So those states are California, Oregon, Washington, Minnesota, New Mexico, Georgia, Colorado. Yeah, those are the 7, right? So if you can quantifiably prove that you've reduced your carbon footprint based on engineering decisions and you've got the documentation to back it up, in those states, you're possibly eligible for tax rebates, tax credits, write-offs, incentives. So it's not just about the footnote of what you saved because your compute spend changed. It's also some back-end benefits as well.
Yeah, and I mean that's probably very true in like other regions as well outside of the U.S., right, where they're meeting compliance objectives and have internal and both governmental kind of almost requirements that need to be met in that case, right?
Yeah, no, absolutely. And we've worked with customers in Scandinavia that are their government's very focused on green ops and sustainable engineering. So they're very passionate about this thread and needling it and making sure that they can get all they can out of it.
And so I was going to ask you too, like, so one of the quick hits and strategies for a green ops, for lack of better terms, like just strategy or play, right, from an operational level, is to move things onto ARM, like you were talking about, ARM-based processors, right? So when we're talking about ARM migration, obviously, I'd love to hear your thoughts on considerations for like the architecture for that and analysis. But like, it sounds like, I mean, just in the conversation we've had so far, like a cost analysis and potential gains for things other than just the raw cost from the CSP need to be considered as well, right? Do you have any kind of thoughts or recommendations around like what other considerations there are, and of course, what considerations regarding the architecture teams might need to make when they're migrating applications onto ARM processing?
Right. I mean, it depends on the workload, right? So you've got microservices, web apps; those are poised for ARM capability. You've also got specific industries that where their workloads are poised for ARM, like genomics, fluid dynamics, weather modeling, etc. So there's some there's some workloads, and then there's some industries where the way their processes work are poised for ARM, but you also have simple things like IoT, right? Another great, probably one of the best examples. So if you've got IoT Edge, you can leverage ARM, whether it's on-prem or you're just leveraging all the some of the longer term IoT compute in the cloud. So it really depends on how your infrastructure is set up, but there's definitely a set use or set list of use cases that are poised for ARM. And then there's also and I don't want to get too specific in terms of vendors, but I'll give you a great example. AMD, for example, their EPYC processor line definitely in most cases can outperform some of the competition, and then also not just from a performance standpoint, but there will be a significant cost reduction and then cascading over to carbon footprint reduction as well. So definitely a lot of interesting choices that can be made on the compute optimization front.
Yeah, and a lot of, well, and of course, there's like a lot of planning and analysis that's going to have to go through that as part of that process as well. Do you have any, like, what have you seen, and what are your basically high level recommendations for organizations that are kind of looking at tackling this as but need to kind of have a little bit more of the operationalization side of, hey, you know, what, how can you set up that analysis with engineers, and kind of how can you get buy-in within the organization to get people to care about this if you're interested in it,
Right.
right?
Well, I mean, it comes down to use cases and dollars and cents, right? So the best thing to do is, that part where in your, grade school or middle school or high school where you had to come up with a word problem yourself, right? And then write the correlating math equation that goes along with it. Well, you kind of need to do that for a lot of these use cases, but you want to make sure that you do it in a way that resonates with your stakeholders. So some of these stakeholders are visual learners. Some of them are, they just look at the numbers. And some of them want to look at the word problem, right? So you want to think about, for every use case you want to present to your stakeholders, the best way to do it is to do one slide, one use case, but 3 different ways to see and look at the data. And if you can do that, then you can get across to all your stakeholders, and that's a great way to get buy-in. So that would be my recommendation.
Is there another way? Okay, so we've talked about like re-architecting, and we've talked about tax incentives as part of, let's call it, our money saving capabilities within this operation, right? Are there any other ways that kind of we can align GreenOps with saving money to kind of convince people that this is something that needs to be focused on and recorded, right?
Yeah, I mean, it could be part of a effort just focused on compute optimization. It could be a part of an effort that's focused on application rationalization or application modernization, because compute optimization really is a subset of that. Or just doing the thread on compute optimization, that might fuel a bigger application rationalization and a bigger application modernization product. So it's not that one doesn't necessarily have to come before the other, but they're definitely symbiotic in terms of initiatives.
Yeah, that makes sense. That makes a lot of sense. I would also like, when it comes to that kind of correlative cost savings and like building that as part of an argument, how significant, when we're talking about like stale resources, right? Or like say cold storage that's just kind of sitting around, or like hot storage that should be cold storage and that kind of a thing. Is there also a significant carbon consumption that's associated with those kind of resources, or is it like not as significant as the cost, right? Where those things could be really expensive, we should deprecate them, get rid of them.
I mean, storage. Yeah, it's a good question. Storage doesn't necessarily compute, and the IO and the compute isn't there unless they're being called upon, right? So things that are in like deep glacier or deep storage aren't necessarily killing the environment, so to speak. Forgive the term, but that's but it's definitely killing your bill. So you want to make sure that your life cycle policies are in place, and that your data tiering policies are in place. Your data purging policies are in place. And I think, the more you do that, the more you're going to see your bill go down. But I think, anything that you can do to reduce cost, will, eventually incrementally, reduce your compute IO as well. So I think it's always worth, looking into that. Like zombie boxes and idle resources that are not being used are great examples where you can reduce compute and reduce spend and reduce, of course, carbon footprint as well. So there's various ways. There are scripts out there publicly available that can help you find these boxes that are not being used. You also within the dashboards of the cloud platforms, there's ways to look at CPU rates and IO is one of the best indicators whether it's being used or not. So, and then also you just want to adopt, especially in the lower environments, some sort of, scream test, right? Just power it off, right? Power it off. If you've got the ability to power it off and it's not a production environment, suspend that for the day and see if anyone says anything, right? And carry that on for a week. And then, whatever internal policy you need to adopt to finally get rid of that box, go ahead and figure that out. But there are ways to get creative here. And I think it's just important to, leverage the knowledge that's out there, but then also, attach your own strategy to it. And then,
Sure. Yeah, and that is, like I know also there's a lot of documentation on that from FinOps.org as part of the capability there too, right? And it really ties in also to that economic story. That's really great. I would be remiss if I didn't also mention that there are tools that can help you, automate the process of finding as well as, taking
that's
care
right.
of those.
That's right. I heard
So,
IBM might provide some of those things.
just a little bit. No, that's great though. But again, other resources and tools at FinOps.org tool, man. This is a really great conversation. I'm really glad that we've been able to kind of get to that level and just navigate it from top to bottom. Cool, man. Well, David, thank you so much for all of this. This has been a really, really great. I feel like it's more of a deep dive into everything that we've been talking about here.
Yeah.
And understanding kind of these different ways. Do you have any other recommendations for people when it comes to this the operation side of things and kind of buy-in and adoption for different organizations?
Well, certainly. I mean, and some of it's not just about green ops, right? It's just about best practices, right? So if you're in Azure, for example, you would want to make sure that your lower environments just have a simple checkbox checked within the cost management portal, and that's to check them off as being dev test workloads. There's a significant meter change in price related to just that checkbox alone, and so it's important to make sure that the admin of some of these things on the back end is sorted out, and you are taking advantage of all of the things that can be done from the cloud providers back end. So some of it's configuration management, right? So if you do not have the appropriate configuration management policies and practices in place, that's also going to lead to increased cost and could also lead to increased compute as well. So that's also going to impact some green ops components as well. So there's a lot of synergy. Like I said, green ops is not another thing for everyone to learn. It's a subset of FinOps. It's part of the cloud economics mantra, and it's FinOps through the lens of sustainability. That's all it is. But I think it's an important initiative, and companies should think about kicking it off. It's important.
Yeah, absolutely. All right, man. Well, thank you very much. Do you have any last words of wisdom for anything or for everyone? And is there anything else that you wanted to say before we sign up on the episode here?
No, I really appreciate you having me on, and enjoyed meeting you in person, and I appreciate you keeping the connection. Thanks, Hunter.
Yeah, absolutely. Thank you for coming on, and everybody on the call here. We want to point you over to FinOps.org. There are some great green ops resources there as well. And also IBM does have a huge resource section for this as well as CDW. David, thanks again. Really appreciate your time. Everybody take care. We hope to see you again next time.
Thanks.